Hi, my name is Nasser T. Iqbal from section ME1D. So here, I will show you some differential calculus problem. Let's begin with our problem number 1, which is f of x is equal to 2x minus 1 multiplied by x minus 4. So in order to solve this, we will use the product rule. So we have f prime of x is equal to, copy the first term, 2x minus 1 multiplied by the derivatives of second term, which is 1, plus, copy the last term, x minus 4 multiplied by the derivatives of first term, which is 2. And then we will just multiply this. Now we have f prime of x is equal to 2x minus 1 plus 2x minus 8. Then we will combine like terms. Now we have f prime of x is equal to 4x minus 9 as our final answer. Now let's proceed with our problem number 2, which is f of x is equal to 3x squared minus x plus 1 all over x squared plus 2. So to solve this, we will use the quotient rule. Now we have f prime of x is equal to, copy the denominator, which is x squared plus 2, multiplied by the derivatives of our numerator, which is 6x minus 1, minus numerator multiplied by the derivatives of our denominator, all over the squared of our denominator, which is x squared plus 2 squared. So we will multiply. Now we have f prime of x is equal to 6x cubed minus x squared plus 12x minus 2 minus 6x cubed minus 2x squared plus 2x all over x squared plus 2 squared. Now we will combine like terms and cancel the 6x cubed. Now we have f prime of x squared plus 10x minus 2 over x squared plus 2 squared as our final answer. So for our third and last problem for this topic, which is y is equal to secant times x plus 3 over sine x. So what we are going to do is we will get the derivatives of the x plus 3, which is 1. Then we have y prime is equal to secant times 1 all over sine x. Then we will use the quotient rule, which is y prime is equal to, copy the denominator, sine x times the derivatives of numerator, which is secant x tangent x, minus the numerator, which is secant, and multiply by the derivatives of our denominator, which is cosine x, all over sine x squared. Now we will multiply this. Now we have y prime is equal to sine x secant x tangent x minus secant x cosine x all over sine x squared. Now notice that the secant x can be cancelled. That's why we can have y prime is equal to sine x tangent x minus cosine x all over sine x squared as our final answer.